right, we're going to take a look at what I like to call mixed factoring. And what that means is up until now, factoring has been a bit organized. We've sectioned off our greatest common factor examples, our difference of squares examples, our trinomial examples, and our four-term examples. So we've always kind of had that separated, so we knew exactly what kind of problem that we are looking at. So now we're ready to mix those problems up. So we have a guide that we're going to follow to help us through this process and how we know how to attack it when given a problem as far as how to factor it. So step one, we want to look for a greatest common factor. That is such a crucial step, and we want to make sure that we never overlook that at the beginning. So then after that, after we've looked for our greatest common factor and we've factored it out if possible, we want to look for one of these special patterns and then factor it further. And sometimes there won't be anything left. Sometimes it's just greatest common factor and we're done. Sometimes it's not even greatest common factor and it's a prime polynomial. But sometimes they do keep going after that greatest common factor. So after we've looked for that GCF, we want to see, is it a difference of squares? Do we have something squared minus something squared? Do we have a basic trinomial, which is x squared plus bx plus c? Do we have a slip and slide trinomial, which is where we have that leading coefficient of ax squared plus bx plus c? Or do we maybe have four terms? So we want to look for one of these special types of problems. And then step 3 is going to be new. We need to see if something factors again. Some of these problems are going to keep going, and this is actually very common, especially with difference of squares. You might factor a difference of squares and have another difference of squares to factor, or sometimes you might factor a four-term problem and then still have difference of squares left over. But so we want to make sure that we look at our final answer, look across it, and make sure we're done. So looking at number 1, we have 28a squared b minus 63b. So right off the bat with step 1, we need to think about a greatest common factor and if this problem has one. So we have 28 and 63 for our coefficients. So there is a greatest common factor for 28 and 63, and that's 7. So we're going to bring that down. Then also make sure we look at our variables. We have a squared b and b. So the greatest variable that goes into both of these terms is b. So we're going to take out the b. And inside, we're left with 4a squared minus 9. Okay, so we've done step 1 on this problem. Step 2, check for one of the following patterns and factor it if possible. So taking a look, I'm going to switch this and underline it in red. We've got to take a look at what we had left over. 4a squared minus 9. We definitely know it's not a trinomial. That it's trinomials are 3 terms and this is 2 terms. It's not 4 terms. So basically we have something with 2 terms. Is it a difference of squares? Can we square root 4a squared and can we square root 9? And we can. The square root of 4a squared is 2a and the square root of 9 is 3. So this is a difference of squares, so we want to make sure that we factor that. So bring down your GCF. Your GCF is part of your answer. Don't lose it. And then we're going to factor this as 2a plus 3 and 2a minus 3. And then we got this step 3 here, right here. The step 3, check to see if something factors again. So we're going to take a look at what we have left over and see, do either of these keep going? These are both only 2 terms. I mentioned before that this is very common with difference of squares, and that's what we have to really be aware of. 2a plus 3, we know that doesn't go anywhere else. It's a sum, it's not a difference. And 2a minus 3, is that a difference of squares? And it's not, because you can't square root 2a and you can't square root 3. So this answer is done. We have factored this polynomial completely. Cannot factor it anymore. So the answer is 7b, 2a plus 3 and 2a minus 3. All right, looking at number 2, 3m squared plus 9m minus 30. Thinking about a greatest common factor first, so let's look at our coefficients of 3, 9, and negative 30. We're able to take 3 out of this. We can't take m out because it's not common to all the terms, so it's just a 3. And inside we have m squared plus 3m minus 10. So I'm going to underline this part. Does that keep going? Is this one of our special types up here? This one appears to be a basic trinomial. So we want to find factors of the last term that add up to the middle term. So I'm going to drop down this 3 so I don't lose it. Factors of negative 10 that add up to positive 3 are positive 5 and negative 2. And taking a look at that answer, you have to just make sure, do either of those factor again. And neither one of them are any of our special cases. So this one is done. Our answer is 3, then times m plus 5 and m minus 2. All right, number 3. Think of a greatest common factor first. Look through your coefficients, and I'm looking through, and you got a 1, 2, 4, 8. So no greatest common factor with the coefficients, and then look through the variables, see if there's a variable common to all 4 terms. This one's not. So we're actually going to skip right over step 1 on this problem. There is no greatest common factor. So then we're moving to step 2. Looking for one of the patterns to factor. This one is 4 terms, so we're going to use grouping. We're going to group our first 2 terms and our last 2 terms, and then we're going to do a greatest common factor of the first 2 terms of x squared. We're left with x plus 2 minus, in the last 2 set of terms, the greatest common factor is 4, and we're left with x plus 2y. This should have been a y here, over here as well, x plus 2y. And then, so we're going to take out our x plus 2y, and then we're left with x squared minus 4 here. So we factored our 4 terms, and now step 3, check to see if something factors again. Do either one of these 2 factors, are they one of our special cases? And if you notice over here on the right, x squared minus 4, that's a difference of squares. So we need to keep this one going. And this is the first one we've seen where it keeps going. So we're going to recopy x plus 2y. And then we're going to factor this as x plus 2 and x minus 2. And then check and see, does anything factor again? And if you look at these 3 binomials, they are all in their most factored form. So we are done. Okay. All right, let's take a look at number 4. We have 4y squared plus 7y minus 2. For this one, we want to look for that greatest common factor always. And this one does not have a greatest common factor. So we're going to skip into our special factoring types. And we're looking at a trinomial with a leading coefficient. So we're going to do some slip and slide here. We have y squared plus 7y minus 8. Factors of negative 8 that add up to 7 are positive 8 and negative 1. And then we have to do our divide by 4. And then reduce and slide up any remaining denominators. 8 divided by 4 reduces cleanly to 2. And 1/4 does not reduce anymore, so we're going to slide it up. So our answer is y plus 2, 4y minus 1. Stop and make sure that nothing else factors again. We have y plus 2 as our first binomial. We would not be able to factor that any further. And then 4y minus 1. It kind of looks like a difference of squares, but the y is not squared. We can't square root 4y. We can square root 4y squared, but we can't square root 4y. So this one is done. Okay. All right, let's look at number 5. We have 45w to the 5th power minus 3w. So greatest common factor is always what we want to look for first. And for this one, our greatest common factor would be a 3 and then a w. So then we're left with 15w to the 4th minus 1. So let's look and see, can we keep this one going? can you square root 15w to the fourth? And can you square root 1? 15 is not a perfect square, so this one, you can't factor that any further. So this one is done. Okay. All right, number 6, we have 24x squared y squared minus 6xy squared plus 3xy. Want to look for that greatest common factor first. So we have 24, 6, and 3. The greatest common factor of those numbers is 3. And look at those variables. You have x squared, then x, then x. There is an x common in all the terms, and the greatest x in all of them is just x. And with the y's, we have y squared, and y. So the greatest y that we see in all three terms is just y. So we have our greatest common factor of 3xy, and then we're going to divide, and we're left with 8xy minus 2y plus 1. Now, looking inside, that is a trinomial, but it's not one of our quadratic trinomials. It's not x squared plus bx plus c. It's got an extra variable thrown in there, y, so it doesn't exactly follow the trinomial pattern that we are used to factoring. So this one was just a greatest common factor problem, and that's it. All right, looking at number 7. For number 7, we have 8x to the fourth power minus 4x to the third power minus 24x squared. So we're looking for a greatest common factor, and for this one, we can take out 4x squared, and then we're left with 2x squared minus x minus 6. Take a look at what's inside those parentheses. Is that one of our special cases? It looks like a trinomial. We have the x squared, the x, and then the no x. And this one has that leading coefficient, so we're going to do some slip and slide here. I would keep carrying down the 4x squared so we don't lose it. So we have x squared minus x minus 6. Minus 12. Forgot to multiply that. Minus 12. So we're looking for factors of negative 12 that add up to negative 1. So that would be negative 4 and positive 3. And then we divide them both by 2. And then we reduce and slide up any remaining denominators. So we have 4x squared, and then x minus 2, because 4 divided by 2 is 2. And we're going to slide up that 2 for 2x plus 3. And we're done. All right, looking at number 8, 64x squared minus 4y squared. Greatest common factor of 64 and 4 is 4. So we want to take that out. Inside, we're left with 16x squared minus y squared. Take a look at what you have left inside and determine, can it keep going? This one can, because that is a difference of squares. You can square root each one of those terms. So we have our 4. The square root of 16x squared is 4x. And the square root of y squared is y. So this is 4x plus y, and then 4x minus y. And then just take a look and verify, make sure that these are not difference of squares and they don't keep going. And then we're done. All right, number 9, x to the third power plus 3x squared minus 5x minus 15. Look for our greatest common factor in the 4 terms. Is there something that we can take out to the side and factor out? This one does not. So this one, we're going to look for those special types. It's 4 terms, so we're going to group. Greatest common factor of x cubed plus 3x squared is x squared. Left with x plus 3 minus 5 with x plus 3. We'll bring out x plus 3 and x squared minus 5. Take a look and see, does this keep going? X squared minus 5, in order to keep that going as a difference of squares, both terms have to be perfect squares. We have to be able to square root these. You can square root x squared, but 5 is not a perfect square. So this one is done. All right, let's look at number 10. K squared minus 6k minus 16. Is there a greatest common factor? Looking through this, there is no greatest common factor, so we're going to skip and look at what kind of factoring problem that is this. And this one's just a basic trinomial. There's no leading coefficient, so no slip and slide. Factors of negative 16 that add up to negative 6 are, let's see here, they're negative 8 and positive 2. These are not perfect squares, so that's it. Basic trinomial, and that's it. All right, let's take a look at the back. And let's do number 14. Take a look at number 14. 9x to the third power plus 9x squared y minus x minus y. Always look for that greatest common factor in all the terms first. See if something can be pulled to the side. This problem does not have a greatest common factor. There's 4 terms, so we are going to group them. The greatest common factor of the first set of terms, we have 9x cubed and 9x squared y, so we can factor out 9x squared, and we're left with x plus y minus, over here we can factor something out. We can take something out. This is one of the cases where we take out a 1. If we take out a 1, we have x plus y. So we can bring our x plus y down, and then 9x squared minus 1. And then take a look and see, do either of these keep going? We got x plus y, that's not a difference of squares, and 9x squared minus 1. This is a difference of squares, and it does keep going. So we want to recopy our x plus y, don't want to lose it. And then we are left with 3x plus 1, 3x minus 1. Right. And that's it. All right, let's take a look at number 20. Number 20 is 100 minus 9y squared. Is there a greatest common factor of 109? There is not. We can't take out any variables. So let's move on. We don't have a trinomial. We're looking at 2 terms here. So is it difference of squares? Can you square root both these terms? Is there a square root of 100? This is why I ask myself, can you square root 9y squared? And in this case we can. So this is a difference of squares. So the square root of 100 is 10, and the square root of 9y squared is 3y. So we have 10 plus 3y. And then 10 minus 3y. And those do not factor further. So that's it. All right, and then let's look at number 22. That will be our last one that we look at together. For number 22, we have 75x squared minus 30x plus 3. So greatest common factor, this one does have a greatest common factor, and that's 3. Take 3 out. And then inside the parentheses, we have 25x squared minus 10x plus 1. All right. So now looking inside the parentheses. Inside the parentheses, I see a trinomial that follows our pattern with x squared x, then no x. And it has a leading coefficient, so we're going to do some slip and slide here. So we have 3, and then x squared minus 10x plus 25 times 1, 25. We need factors of 25 that add up to negative 10. So that's negative 5 and negative 5. And then we're going to divide by what we slipped, which was 25. And then we have to reduce and slide up denominators. So 25 25ths is 1/5. So we're going to have to slide these denominators back up. And so our answer to this one will be 3, 5x minus 1, 5x minus 1. You can also write this one, since it's a repeated factor, you can write 5x minus 1 squared. Okay, you can go through and try the remaining examples, and then you can check your work. Just always make sure that you look for that greatest common factor on the first step always, and then follow the guide from the front, and then look at your final answer and make sure that there's no special factoring types remaining in the final answer. And that's it.